Have you ever wondered what's at the heart of our solar system? It's the Sun, our very own star. This celestial body is the core of our solar system, a grand sphere of hot, glowing gases. It's a giant when compared to Earth, over 1 million times larger in fact. Its immense size is difficult to comprehend, isn't it? The Sun is primarily composed of hydrogen, accounting for about 3/4 of its mass. The remaining quarter is mostly helium, with traces of heavier elements like oxygen, carbon, neon, and iron. These elements are constantly undergoing nuclear fusion in the Sun's core, generating an incredible amount of energy and heat. It's this energy that travels 93 million miles to reach us here on Earth, providing the warmth and light we need to sustain life. Let's talk about gravity. The Sun's gravitational pull is so powerful that it keeps everything in our solar system, from the tiniest particles of dust to the largest planets, in their orbits. It's like a cosmic tether, keeping us all connected and in place. If it weren't for the Sun's gravity, planets like Earth would simply drift off into the cold, dark void of space. But the Sun's influence extends beyond just gravity. It's also responsible for phenomena like solar winds and solar flares. These bursts of plasma and magnetic fields can have significant impacts on Earth's atmosphere and even our technology. The Sun, for all its grandeur and power, is also a ticking time bomb. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, swallowing up the inner planets. But let's not worry about that just yet. The Sun is more than just a bright light in the sky. It's a complex, dynamic star that governs our solar system and makes life on Earth possible. From the warmth it provides, to the gravity that keeps us grounded, to the spectacular light show of a solar flare, the Sun is truly at the heart of our existence. Without the Sun, life as we know it would simply not exist. Moving outwards, we first encounter the rocky inner worlds of our system. First in line, closest to the Sun, is Mercury. This tiny planet, roughly a third the size of Earth, is a world of extremes. Its surface, pockmarked with craters, experiences scorching daytime temperatures that can reach 800 degrees Fahrenheit, while its dark side plunges to -290 degrees at night. No atmosphere to speak of, its sky is a vacuum, making it a silent world. Next we come to Venus, our system's hottest planet thanks to a runaway greenhouse effect. Its thick, toxic atmosphere traps heat, causing surface temperatures to soar to a blistering 865 degrees Fahrenheit. Venus spins slowly in the opposite direction to most planets, and a Venusian day lasts longer than a Venusian year. Then there's our home, Earth, the only place we know of in the universe where life exists. A perfect balance of distance from the Sun and atmospheric conditions has allowed water to exist in all three states: solid, liquid, and gas. This blue marble, with its diverse climates and life forms, is indeed a cosmic marvel. Finally, there's Mars, the red planet. Once it may have been quite similar to Earth, with flowing water and a thicker atmosphere. Today it's a cold, barren desert world with the tallest volcano and the deepest, longest canyon in the solar system. But don't let its current state fool you. Mars holds the promise of past and perhaps future life. Collectively, these four planets, Mercury, Venus, Earth, and Mars, are known as the terrestrial or Earth-like planets. They're called this because they share a common trait: solid, rocky surfaces much like our own world. But that's where the similarities end. Each of these rocky worlds has its own unique set of characteristics and conditions. These rocky worlds, so different yet so alike, each hold their own mysteries waiting to be unraveled. Beyond Mars, we find a cosmic shooting range. This is no ordinary shooting range though, it's the asteroid belt, a vast space filled with a multitude of objects varying in size. Nestled between the orbits of Mars and Jupiter, this belt is a treasure trove of knowledge about our early solar system. Here, countless rocks and metals are whirling around in a cosmic dance, each one a unique piece of the puzzle that forms our understanding of our universal neighborhood. These asteroids are not just random space debris. They are remnants, silent witnesses of the nascent solar system. Each asteroid carries with it a story, a tale of the turbulent and chaotic times that marked the birth of our planetary family. From tiny pebbles to bodies hundreds of kilometers in diameter, the asteroid belt is a fascinating spectacle of cosmic archaeology. It's like a floating museum, holding the secrets of our solar system's history. The asteroid belt, a silent reminder of our solar system's turbulent past. Continuing our journey, we reach the realm of the gas giants. These colossal celestial bodies, Jupiter, Saturn, Uranus, and Neptune, are the heavyweights of our solar system, dwarfing our rocky inner planets in both size and mass. First, we encounter Jupiter, the largest planet in our solar system. It's more than 1,000 times the size of Earth and composed primarily of hydrogen and helium, the same elements that make up our Sun. Jupiter's most recognizable feature is its Great Red Spot, a storm that has been continuously churning for at least 3 centuries. This gas giant is also home to a family of over 70 moons, including Ganymede, the largest moon in the solar system. Next we find Saturn, the second largest planet and perhaps the most visually stunning with its impressive ring system. These rings are made of countless particles of ice and rock, ranging in size from tiny grains to massive chunks. Along with its rings, Saturn boasts more than 80 moons, with Titan being the largest, a moon that even has its own atmosphere. Moving further out, we encounter Uranus and Neptune, slightly smaller but still gas giants. Both planets are characterized by their striking blue hues, thanks to the methane in their atmospheres. Uranus, unique among planets, rotates on its side, likely due to a colossal collision in its past. Neptune, the furthest gas giant from our Sun, is home to the strongest winds in the solar system, reaching speeds up to 1,500 miles per hour. Each of these gas giants holds unique features and mysteries waiting to be explored. From Jupiter's enduring storm to Saturn's icy rings, Uranus's sideways spin to Neptune's supersonic winds, they all offer a glimpse into the diversity and wonder of our solar system. These gas giants, with their swirling storms and spectacular rings, are truly a sight to behold. At the very fringes of our solar system we find the Kuiper Belt and beyond. This vast, cold region extending from the orbit of Neptune to approximately 50 astronomical units from the Sun, is home to a multitude of icy objects. These icy remnants, left over from the formation of the solar system, are the silent sentinels of our cosmic neighborhood. The Kuiper Belt is akin to a cosmic freezer, preserving ancient objects composed primarily of frozen volatiles, such as methane, ammonia, and water. These icy bodies, often referred to as Kuiper Belt objects or KBOs, vary in size from small chunks of ice to dwarf planets. Speaking of dwarf planets, let's not forget the most famous resident of the Kuiper Belt, Pluto. Once considered the 9th planet in our solar system, Pluto was reclassified as a dwarf planet in 2006. Despite this demotion, Pluto remains a fascinating world, with its complex surface features, intriguing moons, and an atmosphere that expands and contracts with its highly elliptical orbit. Beyond the Kuiper Belt, we venture into even more mysterious territory: the Oort cloud. This hypothetical region of space is thought to extend from about 2,000 to 200,000 astronomical units from the Sun. Although it has not been directly observed, the Oort cloud is believed to be the origin of long-period comets. The Oort cloud is like the final boundary marker of our solar system, beyond which interstellar space begins. It's an icy shell enclosing our solar system, a repository of ancient comets, and a testament to the vastness of our cosmic neighborhood. The exploration of these distant regions poses significant challenges, but also offers the potential for incredible discoveries. Each icy object holds clues to our solar system's past, and offers insights into the formation and evolution of other planetary systems. From the Kuiper Belt to the Oort cloud, these distant regions are our solar system's final frontier. Our journey through the solar system has been nothing short of extraordinary. We've traversed the celestial neighborhood, starting with our home star, the Sun, with its overwhelming energy and gravitational pull. We've hopped onto the rocky worlds, the inner planets, each with its unique characteristics and mysteries. Next, we navigated through the cosmic shooting range known as the asteroid belt, a chaotic realm of rock and metal. We then ventured into the realm of the gas giants, immense planets of swirling gases and fierce storms. Finally, we reached the outermost regions of our solar system, the Kuiper Belt and beyond, a frontier filled with icy bodies and the potential for undiscovered dwarf planets. The vastness and diversity of our solar system is truly mind-boggling. It's a cosmic playground filled with wonder and knowledge waiting to be discovered. As we continue to explore and learn, who knows what other wonders our solar system holds.